find me the resultant. So I'm going to take this force right here, and I'm going to move it along its line of action and place it right there. There's my 250. I'm going to take this vector right here, 375, and I'm going to move it head to tail to the first one. I'm going to make it a little bit longer. Go to 375 versus 250. And then from the tail of the first to the head of the second, I'm going to draw my result. That's step one. There's my head to tail right here. And it doesn't matter whether I do 250 added to 375 or 375 added to 250. It doesn't matter. Okay? If I do it the other way, I'll get the other half down here of the triangle, which is the other half of the parallelogram. Now the big question is, what are these frickin' angles? Well, I'm going to draw a horizontal line, which is in essence parallel to that X that you see. This angle here has to be 45. Yes? I'm going to draw a line right here, which in essence is perpendicular to the Y. That angle is 30. Yes? Well, what's this angle if that angle is 30? Let's put it this way. This right here would be 60 if this is a 90, which means that angle's got to be 60. Now, I'm going to call this beta. Beta is equal to 180 minus 60 plus 45. Beta is equal to 75 degrees. Now what I have is two sides, 250, 375, and the angle in between the two sides. What's that lead me to? Law of cosines. So now I can say r squared is equal to 250 squared plus 375 squared minus 2 times a, 250, 375, you can't see, I'm sorry, and then the cosine of the angle in between. Now you whip out your calculator and solve that. If you do, you're going to find that r is equal to 393.18 pounds. But that's only half of the story. Because for vectors, the story is magnitude, I found, and then you have to give me direction. Right? Well, what's the direction? How do I get direction? Direction is given by law of sines. This is law of cosines. I need the law of sines in order to get angles. I'm going to call this angle theta. I'm going to call this whole thing angle phi. So now I'm going to say sine of phi and the side opposite phi, that would be the 375, is equal to sine of 75 over 393.18, which equals sine of theta over 250. So in the law of sines, it's always the angle and the side opposite that angle. And it doesn't matter whether you put the 375 up top and the sine down there, or the sine here and the 370. It doesn't matter, it's a ratio. So now I need to solve. I'm going to solve for phi. Phi is equal to 67.11. So in essence, all I do is I take these two together and solve. How the hell do you do that? The answer is easy. I take this times this times this, and then eventually, like an algebraic equation, solve for phi. Which means I got to take the sine inverse of whatever those numbers are. Yes? Now, that's not an answer that I'm going to find in the back of the book. That's not an answer I want from you. I want an answer that is from the x or from the y. So I want a value that is from the x or from the y. So my answer would be 393.18 pounds at this angle here, which is 97.11. Or you could just give me this angle, which would be that angle right there, which would be 7.11. So I'm going to take either of those answers from you. Now, what the book would want you to do is give me that obtuse angle right there, which would be the 352.89. I don't want that obtuse angle. That's not the angle I want. I want either this one or this one. I prefer this one because it's the acute angle. Yeah. Don't give a shit. He asked me, hey, do you want me to find theta? I don't really care because theta is immaterial to me. I just need an angle that the resultant makes with the horizontal or with the vertical. That's all I care about. I personally would probably write this answer as 393 angle 7.1, in essence in the fourth quadrant. If this is quadrant 1, 2, 3, that would be the fourth quadrant. Okay? That's the answer I'm looking for. The textbook wants you to give them the 352. From the positive x all the way around to get to the vector. Alright? Now, that is by no means the easiest way to solve the problem.
Professor?
Yeah?
Can you show me how you got 97 again? You got.
Well, this was 63 or 67 plus the 30. 67 plus the 30 gives me the 97 from the vertical. So from here down, that's the 67 plus the 30. Now, by no means is that the easiest way. Here's the easiest way, of course. There is the component method. I took x and y. I took the two magnitudes, 250, 375. Found the x component, 250 sine of 30. 250 cosine 30 gives me the y. I did the same thing for 375. 375 cosine 45. 375 sine 45. Pay attention to the little details. Oh crap, I gotta put a negative sign on the 375 because it's acting downward. Right? It's component. So here are the components. There's the fx. Here is the fy. That right there is a negative fy. That's why you see a negative there. Does that make a huge impact? Yeah, because your final resultant is a negative 48.63. So now I have in Cartesian vector form 390i and then a negative 4863. Well, if you square, add them together, take the square root, I get 393.14. Yeah. The result is what?
A little different. The last one was 393.18.
How many decimals do you keep? Listen, when it comes down to, you give me 393.14 or you give me 393.18, you really think I'm going to take all points? Does it really?
Yeah.
Because I got 7.11 here anyway. I had 7.11 before. I'm not going to be picky to the point where if you give me 1.4 versus 1.8, I'm not going to say, oh, that's wrong. No. How many decimals did you keep? That's going to alter your final answer, for sure. That's why I've told you in 3D, I need you to keep 3 decimals. Because I keep 3 decimals. So if I keep 3 decimals there, you keep 3 decimals, we should come up with the same answers. Right? Hopefully. So, here is the component method of the same thing. Any questions on either way? Component method or straight up parallelogram? On the quiz, it's going to say no credit for component method. You're going to have to do it this way. I liken this to when you did calc, you took derivatives by limits. That would be this method. Then they came along and said, hey, you can really use the quotient rule, or the product rule, or the power rule. And you're like going, oh crap, that makes life much easier. I don't have to do all those limits and all that algebra that goes along with limits. Why the fuck didn't you tell me this before? Right? Questions before I move on? Yeah.
Can you write out how the algebra to solve?
How the what?
Can you write out
Solve for phi? You're shitting me, right? My God, what did we come to? So I'm going to say 393.1. By the way, this isn't statics, this is math, which you should know how to do by now. I want to be an engineer, but I suck at math. Go to business school. It's that simple. Go to business school. 393.18 sine of phi is equal to 375 sine of 75. I multiplied both these together like that. Sine of phi is going to be 375 sine 75. Divide this by 393.18. Therefore, phi is equal to sine inverse of 375 sine of 75 divided by 393.18. Can you whip out your calculator and do those, please? Okay, thank God. Questions? Huh? Yeah.
Is there any like real life
Okay, that kinda makes
where
sense.
you would use
It-
the
but
tail
at least a little bit.
No.
Okay.
No.
I was just wondering.
No, the head to tail method is it's academic, whereas the compound method is what you might use outside the real world.
Can you flip the wall sign to the order? That's your sign of E.
That's correct. It doesn't matter. It's a ratio. I can put them wherever the hell I want. Usually the way I do it, you can see the known quantities in the middle, so I take this side Or I can go and solve that side. So I can solve this side or that side, depending on what I'm looking for. But no, it doesn't matter where you put what. Like I said, you can put the numbers up top and the signs on the bottom. You can switch them while there, it doesn't matter.
That actually explains a lot about it.
Questions?
Because there's no thing for it. Okay,
Yeah.
that makes a lot of sense now, Chris. Because it was
You get what? What final part?
Chris makes some sense over there.
Getting to 9711 or this one? How are you having trouble getting there?
Yeah, this makes more sense.
I'm not following, because here's what you have. There's the resultant, I know that's 30. If I draw a horizontal line, that's 60, because that's gonna be 90, agreed? Which means that's 60 by alternate interior angles. This was 45, 180 minus 45 plus 60 is 75, agreed? We then calculated, I said this was phi, right? So I said, hey, this is phi. And I said, this is theta. So when I calculated phi, I got 67.11. So now, I'm looking to find that angle. Or I'm looking to find this angle. Well, that's 67 here, plus the 30, that's 97.11. Right? You didn't see that. Well, now you should hopefully see it. All right. What happens when I give you a problem where there's a ton of numbers? Well, yeah. Say that again. What about it? I needed to go at the tail. Yeah. One could be in tension, one could be in compression. You can flip. All right, so I got this, and I've got 1, 2, 3, 4 forces. If I were to do this the way that you've been in essence taught, it would be this. By the way, notice, given, find, blah, 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 right? What did I do here? I went ahead and said, all right, I'm going to add F1, F3, F2, F4, and from the tail of the first to the head of the last, I'm going to write my result. And it doesn't matter what order you put them in, I just happen to put them in this order. F1 plus F3 plus F2 plus F4, connect the tail of the first to the head of the last. Boom, there's my result. Well, guess what? What do you get? A freaking polygon. Do you know how to deal with polygons? I don't. I mean, I'm sure I can look it up in some book and Google it or whatever you do these days, but I'm not going to take that time to do that. So what's my alternative? Break it up into pieces that form triangles. So here's my solution to this problem. It is, I'm going to take the 80, the horizontal. To that, I'm going to add the 40. Notice 45 here, 45 there. And from the tail of the first to the head of the last, I'm going to write R1. R1 because this is really the true resultant of all four. It's only the resultant of the 80 plus the 40. So you can see what I'm doing. I'm breaking it up into pieces that form triangles. Why? Because I love triangles. I know triangles. I know the law of cosines. I know the law of sines, etc. Yeah? Notice, law of cosines, law of sines. Here's my answer for the resultant. Now I'm going to take that resultant and I'm going to add it to this 40 at 45. Does everybody see what I'm doing? So if you had to, and I would never ever suggest you do it this way because it is a pain in the ass, right? There were how many forces? 4, which means how many triangles am I going to create? 3. And how many law of cosines? How many law of sines? Yuck. Why would I want to do that? I would do components in a heartbeat for this. Because it's too long and tedious to do it the other way. So now, here's the next step. Next step is, let's take R1 that you just found. There it is at that angle. I'm going to add to it the 40 at 45. Total angle in here is 59.64. Again, the law of sines, law of cosines, yuck. Right? Yuck. 100% yuck. To get the next resultant of those two, which is 97.98 at an angle of 35.27. I'm going to take that R2 and add it to the last vector, which was the straight down one. So here it is, R2, head to tail to the last vector, which was straight down 30 pounds. And then again, I'm going to apply the law of cosines and law of sines. In this case, that angle is this, which is 54.73. I finally get an R3 of 84.29 and the angle to be 18.4. That is the long, drawn-out way to solve for 4 forces and finding their result. So you just piecemeal it, piece by piece. Take 2, find a resultant. Take 1, add it to the resultant, find another resultant. Take that resultant, add it to the next vector, find another resultant. Okay? Notice 84.29, and it's at an angle that's pointing in essence into the first quadrant. Where I put them head to tail and got a polygon, where was the resultant? In the first quadrant. Right? It's exactly what that's saying. I didn't get the angle here, but it happens to be 18.4. Yeah?
So what is the test if there's always that vision?
Absolutely. Unless you're told no credit for the component method. And in 30 years, I've never done that.
It's not
Today's not the day. You're not, it's only 2 on the quiz, 2 forces. And it's going to say no credit for component method, so you're going to have to do head to tail, law of sines, law of cosines for the one on the quiz. If I gave you 3 or 4 vectors, I would probably just say solve for the result. Up to you how you want to solve it. Do you want to solve it using law of cosines, law of sines? By all means, have at it. If you want to do components, by all means, have at it. Okay? But I'm not going to, in 30 years, I've never given 4 vectors, 4 forces and said, use the triangle construction to solve this thing. That's not what I'm going to do. Okay? So that's how you would do something like that. Now, what would I do? Well, what I would do is the component method. Look how nice and simple the component method is for the exact same problem we just did using head to tail triangle construction. There's the full forces. There's the components. The x component's 8, the y component's 26 squared. How are we going to take the square root? You get 84.29. Pretty much the same answer we had before when we did it using triangle construction, law of sines, law of cosines. Yes? What's the angle? Simple. Change an inverse of the y's over the x's, 18.4, which is exactly what we had before. But you tell me which method is the method you would more likely want to use. This one, of course. Why would you want to go through law of sines, law of cosines, head to tail, 3 triangles, blah, blah, blah? That's a pain in the ass. That's like me saying you can't take a derivative using the product rule, you gotta use limits. Duh. I bet if I gave that, nobody would know how to do that, right? Would you? Thought so. Does anybody remember the quotient rule?
Yeah.
Quotient rule? Okay, thank God. So what you're telling me is you remember calculus, but you don't remember your geometry and trig very well. Years. Okay, let me get, how many taking dynamics? Anybody taking dynamics? Not now, but would. How many are going to take dynamics? Okay, guess what? There's one method called the instantaneous center method that is purely a geometry trig problem. You take all of the dynamics and it reduces down to a geometry trig. So if you don't know geometry trig, you can't solve the problem using IC method. Oops. And if you're mechanical, you're going to see the IC method. How many mechanical? Brush up on your geometry and trig. Hopefully this class is kind of helping you do that. Just so you know. All right, any questions on this one? Using the component method. Pretty simple, straightforward. Understand, no matter what you do, you're still obeying the parallelogram rule. So when I look at this, I have a x and a y. So let me go back here. This has an x and a y. This has an x and a y. So this x is negative, that is positive. This is positive, positive, that's negative. Notice, head to tail, head to tail. You're still obeying the parallelogram rule when you do components. Because when you break things up, you've got to break them up so that the components are head to tail to each other. Okay? Yes? All right. Next problem. Here's the next problem. It says, given the component of F along the AA axis. So F is right here. The component here is along the AA, and its value is 30 pounds. Tell me the magnitude of F and the component of F along the axis BB. What type of problem is this? You got a 50-50 chance. It's a resolution problem. What type of problems have we been solving? Resultant or resolution. That's it. That's what chapter 2 is. Resultants, resolution. 2D, 3D. Done. That's all we're doing. Right? Resultants and resolutions. That's it. What type of problem is this? Resolution. How How many ways can I break a force into components or resolve a force? How many ways? There are 2 ways, but infinite. Which one is it? I know we're on this side of campus where it's pink one day, blue the next, and shades of gray in between. Our college requires one answer. What's the answer? There's infinite number of ways, except we engineers like 2 very specific ways. One, where we know the line of action of the 2 forces that you're resolving to, or when I know one of the components. Those are the 2 that we care about. Why? Because in the real world, that's exactly the 2 that happen the most. I want to resolve a force along this axis and that, so I know the line of action. Or I tell you, these are the 2 lines of action. This one, I need only 30 pounds in. What is this value on this axis? Okay? So this one is the latter. That's the one that is the latter of the 2. You know a line of action, and you know one of the components. So I'm going to take BB, and I'm going to draw it right there. I'm going to take AA, and I'm going to draw it right there. Those are the 2 axes. This is AA, BB. And I drew them pretty much parallel to what they were before. I'm going to put in here my force, which is F. I don't know the value of F. I'm asking you for the value of F. I'm then going to draw a line parallel to AA, and I'm going to connect it to BB. So here is this, which is parallel to AA, which means FAA is 30. That was given to me in the statement of the problem. Yes? What do I know? Well, I know this is 60. What's this angle here? What is it? 20. These 2 lines are parallel. If that's 60, that's got to be because of alternate interior angles. That's that geometry shit coming back to haunt you. So this is 60. What else do I know? From the force to B, this is 80. Well, this angle is theta, and I'm going to say theta is equal to 180 minus 60 plus 80, which is, theta is equal to a whopping 40. Right? So I now know all the angles and one side. What does that lead me to? Law of sines. Any resolution problem is a law of sines problem. Any resultant problem is a law of cosines. Just so you know. So now I'm going to come in and I'm going to say 30 over sine 80. The angle and the side opposite must equal to F over sine 40 must equal to FB over sine 60. So now if I solve these 2 together, which we know how to do, right? What the fuck are you doing? What was that game? Who's gaming? It's a dumb game. Your act was a dumb act. Being in class, put the fucking phone away. I know you did it already, I don't need to listen to you anymore. What would your mom think of you right now? Exactly. It's exactly what I said. What the hell are you doing? Jeez. You're killing me, man. So if I solve this, f is equal to 19.58, and if I solve this and this, or this and this, because I already have the 19, FB will be 26.38. Of course, pounds. That's a resolution problem. A resolution problem where you know one of the components. I did a resolution problem in the pro copy where you knew the lines of action. The U and the V were the lines of action. And you were to break it down along the U and V axis. Here, you don't know the force, but you know one of the components, and that one component was along the AA axis, and it was 30. So now you can find the force itself and the other component. Who's not with me? So again, this is still head to tail. There's the head. I'm bringing this to the tail of FB. Still head to tail. Questions? Nothing? Everybody good on this? All right. Next problem I want to do is this one. Determine the magnitude and coordinate direction angles of the resultant forces. 3D. What's the first thing you look for in 3D? The coordinate system. Is this Himmler's? Yes. Okay. Himmler's coordinate system. After that, what do you look for? It's a 3D problem. You check off. Look, it's like a checklist. Coordinate system. Check. What's the next thing? Next thing is, hey, how did Nora give me information in 3D? Did he give me alpha, beta, gamma? Well, did he? Did he? Yes, he did. There's my alpha, there's my beta, and there's my gamma. Yes? Now let me ask this question. Alpha, beta, gamma, true or false? Alpha, beta, gamma are measured with respect to the positive x, y, z axis. Huh? That's true. That's how they're defined. Alpha, beta, gamma are defined with respect to the positive x, y, z. What do you have here? That's with the negative z. Right? So you better put a negative sign on it. You better put a negative sign. Second way he can give you information is double projection. Do I have double projection here? Oh yeah. Oh yeah. The beauty of the textbook is he can have lightly shaded blue, darkly shaded blue to tell you it's a double projection. On the test, on a quiz, you won't have that luxury. Okay? And that's a double projection. So, I need to express these in terms of IJK and then find the resultant by adding the i's, j's, and k's together. So I'm going to say F1 is 350 cosine 60i plus 350 cosine 60j minus 350 cosine 45k. That's huge. That minus sign makes all the difference in the world. Because what I should have done, I should have measured the gamma from here to there. That's technically my gamma. From the positive to the force. But I gave you 45, which in essence is the complement, no, the supplement of what I gave you for gamma. So 45 plus this angle should equal 180. All right, so F1 is going to be 175I plus 175J minus 247.487K. Notice 3 decimals. For 3D, I always carry 3 decimals. Sometimes I get, I tend to forget to carry 3, but the majority of the time I carry 3. And for sure, on any problem I give on a quiz or test, my solution will carry 3 decimals. For sure. Okay? Now, what about the double projection? Oh, it's given it to me in terms of slope. Does that matter? That shouldn't. If you don't like slope, find me the angle. How would I find the angle here? Tangent inverse of 3 over 4 will give me the angle in here. If you want to do angle. Tangent inverse of 3 over 4, because it's 3 vertical, 4 horizontal, I would get this angle. I don't need to. I can work with that and say this is 250 times 4 over 5. What does the 4 over 5 do for me? The 4 over 5 tells me that angle, which now puts me on the line to nowhere. Where is my line to nowhere? It's right here. Here's my line to nowhere. There's my LTN. Yeah? This has now put me on the line of nowhere. Somebody tell me what the tangent inverse of 3 over 4 is. 36.87 degrees. All right, somebody, you got your calculator. Somebody tell me what the cosine of 36.87 degrees is. I'm going to venture to say it is 0.8. It is, of course it is, because 4 over 5 is 0.8. So really, that 4 over 5 is saying this is representing cosine of 36.87, which is what you want to do to swing it to the line of nowhere. So this angle here is 36.87 if you want to do it by angles. I think you should start getting used to this 4 over 5 crap. Plus, no, minus 250 4/5 sine of 30j. Why minus? Well, because when I do this, sine is the opposite, which is parallel to the y, but that is pointing in the negative y direction, so I gotta put a negative on it. And then I'm gonna say plus 250 times 3/5. 3/5 puts me on this line, which is parallel to my z. Answer, F2 simplified is 173.205i minus 100j plus 150k. Resultant is F1 plus F2. But before I do the resultant, is any problems with what I've done? Go ahead. Say that again. In the, oh, you're right. Great eyes. Thank you for finding that. That would be cosine 30i. I got off on a tangent and forgot to put in that rest of it. Good, you get a star for today. Does everybody understand what we did? So without that cosine 30, I'd still be on the line of nowhere. So cosine 30 swings me to the x-axis. Yes? Any questions on what we did with 1 and 2? Key elements here is that negative sign there is huge. That's huge. And the reason for that is because it is being measured relative to the negative z direction at 45. If you want to do it relative to the positive z, you'd have to say cosine of 135. Well, cosine of 135 gives you the negative automatically. Okay? So, now all I have to do is add i's. That's going to be 348.205i. I'm going to add j's. That's going to be plus 75j. And I'm going to add k's. So that's going to be minus 97.487k. Yeah? I can now find the magnitude. Square root of 348.205 quantity squared plus 75 quantity squared plus a negative 97.487 quantity squared, square root of that. This tells me magnitude of the resultant is 369.29 newtons. And now, that's magnitude, I need direction. Direction is given by alpha, beta, gamma. Alpha. Cosine inverse of fx over f. In this case, it would be cosine inverse of 348.205. Divide this by 369.29, giving me 19.5 degrees. Beta is cosine inverse of Fy over F, which is cosine inverse of 75 over 369.29, which gives me 78.3 degrees. Gamma, cosine inverse of Fz over F, giving me cosine inverse of negative 97.487 divide this by 369.29, which gives me 105.3 degrees. Those are all my angles, alpha, beta, gamma, for the resultant. Any questions on that? Yeah? Go to the first part of the problem? Which part? That one or this one?
Yep.
These are alpha, beta, gammas given. There is no LTN here. It's not a double projection. This is alpha, that is beta, and that is gamma negative in essence. These are all alpha, beta, gammas, and anytime I give you alpha, beta, gamma, or the book gives you alpha, beta, gamma, it's cosine alpha, I, cosine beta, J, cosine gamma, K, I. There is no sign, there is no nothing. It's just cosine alpha, cosine beta, and cosine gamma. Okay? This one is, of course, a double projection. So I'm taking this force, swinging it to the line of nowhere first. Line of nowhere is very descriptive. It is a line that is not going to an X, Y, or Z, or parallel to X, Y, or Z. That's why we swing it cosine 30, and it lands me on the X. Sine 30 puts me parallel to the Y, and then I simply just say 3/5 puts me on a line parallel to my Z. Yes? Yeah.
In F1, the IJK, why do you do cosine 40 for J?
I said 350 cosine 60. That's 60. That's 60, not 40. Cosine 60. There you go. Yes. Oh, you only get one today. Yeah, all right. All right, pick the better one. Are you talking about the first force? Okay. That is correct. So I'm here. So my pen is the vector. I swing it to the line of nowhere. It's there. And then to get to a line parallel to the y, I'm going to have to say sine of 30, which puts me opposite. So I'm here, and then I swing this 30 degrees. Which way is my pen pointing? In that direction, which is in the negative y direction. So I have to put a negative on it. That's why there's a negative there. What's the second question? You have no choice. That's why the identity's there. That's why the identity is important. If you are a betting person, you think I'm going to give you alpha, beta, and gamma?
Yes.
I am literally telling you what I'm going to do before it happens to you. Now, what I'm going to do, am I going to give you alpha, beta, and leave out gamma? Am I going to leave out beta, give you beta and gamma, leave out alpha? I don't know. But I'm going to leave one of those fucking angles out. It's that simple. Why? To force you to do the identity. And then, the best part is, force you to make a decision. Do I take the acute angle or do I take the obtuse angle? Oh crap. Did everybody see that? Did everybody hear that? So you know damn well I'm gonna leave out an A. Agreed? We all agree on that? It's gonna happen. Which means I better freaking learn the identity. Which means I need to apply the identity on the test. Great. Well, that identity, since everything's squared, cosine squared alpha, cosine squared beta, cosine squared gamma, since everything is squared, when I go back and solve for everything, I'm going to take the square root of something. Well, the square root of something is going to be a positive or a negative. Right? Which means I'm going to do, when I take the cosine inverse, I'm going to have an acute angle and I'm going to have an obtuse angle. Now, you have to make the decision, hey, do I take the positive, do I take the acute angle, or do I take the obtuse angle? What's the difference? The difference is the acute's going to give you a positive, the obtuse is going to give you the negative. So if you choose the wrong one, you're going to be off by a negative number. That's it. But when you're off by a negative, the whole answer is wrong. Because you ain't getting the right answer once you have a minus sign error. So I like leaving out an angle because it forces you, A, to remember the identity, and B, make a decision. Because you know what? When you get outside the real world, you're going to make decisions on a daily basis. Especially if you're in charge. If you're a project manager of something, people are going to come to you, hey boss, what do I do with this? You got to make a decision. Hey, we have this problem, what do I do? You got to make a decision. That is why they made you the boss. That is why they're paying you more than the person asking the question. You have to earn that pay. I know, it's a crazy idea that I have to earn my pay. What do you mean? I just hand out and they put money in me. No, it doesn't work that way. Sorry. You really actually have to work for your money. I know, it sucks. What the fuck is that? Yes! The acute angle will give it to you as a positive always. Always. No, there's no other, there's always. Because when you take the cosine of 30, it is 0.866. You take the cosine of, 120, you'll get a negative 0.866. So one's an acute, one's an obtuse. Cosine 60 is going to give you 0.866. Cosine 120 is going to give you the same number, but it's going to give it to you as a negative. Well, which way is the vector? You don't just flip the vector. You've got to see the diagram and decide from the diagram, is it the acute or is it the obtuse? Absolutely, yes. Without the diagram, you can't make a decision. Yeah, there's no way you make a decision without the diagram. Based on the diagram. I can't sit there and say, I picked the obtuse. No, sometimes I pick the obtuse, sometimes I pick the acute, based on the diagram and what the forces are that is in the diagram. I cannot tell you, hey, you're going to always pick the acute or you're always going to take the obtuse. I can't say that. It's based on the particular problem. Okay? All right, I just want to show you this and then we'll take the quiz and get out of here. Remember we did a problem. By the way, you should try this problem. I believe it's under files. I think somewhere it says 3D resultant problem or something like that under files. Try this one. I'm going to do this one next week. And the reason I want you to try it is, it's a little different than what we just did today. Yes, you can see there's a double projection. But the wording, read the wording, you'll see that it's different than what we did today. Today was a straight up, here's two forces, give me the result. This wording is different. Okay? So I would like for you to try this problem, and you never know. I might say turn it in for homework. So make it nice and neat. Okay? And again, the reason I keep trying to tell you, hey, by the way, you should always, 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 always do more problems. Why? Because the more problems you do, the more variations you see. So this looks like a problem we just did. Got a double projection, got another force, two forces, no big deal, but it's the same problem. No, it really isn't the same problem. You don't solve it exactly the same way. That's why I asked you, please do more problems so you get variations. I try to give you as many variations as I can in class. And what I don't cover in class, I try to reinforce in the help session. But again, I can't cover the gamut of problems that you might encounter. And that's why the 5 problems per day is my established rule, so that you get enough sampling of problems, so that you're not caught off guard when the test comes. Okay? Try this one, and we'll go from there. We'll do this one next week. Missed something, I'm going to put these up here. You can certainly probably take pictures of this stuff. If you want to, if you don't, that's fine, you don't have to. All right.